Take a look at this roller kiln. Right now, it's operating at nearly 1,160 degrees Celsius. But here's something most people never think about. If the temperature changes by just 1 degree, even for a few seconds, thousands of ceramic tiles could be ruined. So, how do modern roller kilns keep their temperature this incredibly stable? The answer isn't the burner, it's the control system, a thermocouple, a PID Thermo-Regulator, and a servo-controlled gas valve. Let's find out. Every ceramic tile begins its journey inside one of the harshest manufacturing environments on Earth. Inside an industrial roller kiln, temperatures can exceed 2,100 degrees Celsius. That's hot enough to permanently transform raw clay into a dense, high-strength ceramic product through the process of sintering. But here's the question. How do engineers keep a kiln at exactly the right temperature for hours without overheating the product, without wasting fuel, and without damaging thousands of ceramic tiles? The answer isn't a single machine. It's a perfectly coordinated team of 3 components, working together in a closed-loop temperature control system. The thermocouple, the PID Thermo-Regulator, and the servo-controlled gas valve. Together, they continuously measure, calculate, and adjust the kiln's temperature with remarkable precision. In this video, we'll explore how these 3 devices work together to achieve the accuracy required in modern ceramic manufacturing. Imagine driving a car with your eyes closed. That's exactly what a kiln control system would be doing without a thermocouple. Every reliable control system begins with one essential requirement: accurate measurement. A thermocouple is made by joining 2 different metal alloys. When the measuring junction is exposed to heat, it generates a tiny electrical voltage through a phenomenon known as the Seebeck effect. Although this voltage is only a few millivolts, it accurately represents the kiln's temperature. Modern industrial kilns commonly use Type K, Type S, or Type R thermocouples, depending on the operating temperature and the required measurement accuracy. The thermocouple continuously sends this electrical signal to the PID Thermo-Regulator. This real-time feedback allows the controller to know exactly what's happening inside the kiln at every moment. Without reliable measurement, no control system can function. Because before you can control temperature, you first need to know exactly what it is. But measuring temperature is only half the job. Someone still has to decide what to do with that information. This is where the PID Thermo-Regulator takes control. Think of it as the brain behind the entire temperature control system. Its job sounds simple, but it's one of the most important tasks in the entire firing process. The controller constantly compares 2 values: the set point, or SV, the temperature you want the kiln to reach, and the process variable, or PV, the actual temperature measured by the thermocouple. The difference between these 2 values is called the error. The controller's goal is simple: keep that error as close to 0 as possible. And it does that using PID control. First, proportional. This is the immediate response. If the kiln is too cold, it demands more heat. As the temperature gets closer to the target, it gradually reduces the output to prevent overshooting. Next, integral. This part remembers the past. If the kiln stays just a little below the target, it keeps making small corrections until that remaining error disappears completely. Finally, derivative. This part looks ahead. It watches how quickly the temperature is changing. If the kiln is heating up too fast, it starts reducing the output before the target is reached, just like easing off the accelerator as you approach a stop sign. The result is a smooth, stable, and highly accurate firing curve, working together. In an industrial roller kiln, this process doesn't happen in just one place. The kiln is divided into multiple independent heating zones. Each zone has its own thermocouple, its own PID Thermo-Regulator, and its own servo-controlled gas valve. The thermocouple measures the temperature. The PID controller calculates the correction, and the servo valve adjusts the gas flow, all in real time. Every control loop works independently, but together, they create the precise firing profile needed to produce consistent, high-quality ceramic tiles from start to finish. Even the best PID, thermoregulators, and thermocouples don't stay perfectly accurate forever. After years of working in extreme heat, small measurement errors can start to appear. That's why calibration is so important. Calibration compares your system with a certified reference standard to make sure the temperature on the screen matches the real temperature. Inside the kiln, without regular calibration, the controller might display 1,140 degrees Celsius, while the actual temperature is significantly different. And even a small error can lead to serious problems. Glaze defects, incomplete firing, or weak, unreliable ceramic products. That's why engineers calibrate their systems on a regular schedule. Because in the end, even the smartest controller can only make good decisions if it's working with accurate data. This is where the final member of our trio comes into action. The servo-controlled gas valve is the muscle of the temperature control system. It receives the controller's command and turns that electrical signal into physical movement. After calculating the required output, the PID Thermoregulator sends an analog control signal directly to the servo actuator. The actuator responds by rotating to a precise position. That movement adjusts the gas valve inside the gas multiblock. As the valve opens, more natural gas flows to the burner. The burner releases more heat, and the kiln temperature begins to rise. As the kiln approaches the target temperature, the controller gradually reduces its output. The servo actuator responds immediately. The gas valve closes proportionally. Gas flow decreases. The burner's firing rate drops, and the kiln stabilizes at the desired temperature. Unlike a simple on-off valve, a servo-controlled valve never operates in just two positions. Instead, it continuously adjusts its position. Every small movement changes the amount of fuel supplied to the burner. This allows the burner to match the kiln's thermal demand in real time. In many industrial kiln systems, this precise modulation also helps maintain proper combustion conditions. The result is better fuel efficiency, more stable burner operation, and more consistent product quality. Reaching the target temperature is only part of the firing process. The most critical stage begins during what engineers call soak time. This is the period when the kiln holds its peak temperature for a carefully controlled amount of time. During soak time, several important changes take place inside the ceramic body. The clay particles continue to sinter. The material becomes denser. The glaze melts, flows smoothly across the surface, and develops its final appearance. Internal stresses are gradually relieved, and the entire tile reaches a more uniform temperature. This allows the ceramic body to develop its final mechanical strength. If the soak time is too short, firing may remain incomplete. The glaze may not mature properly, and the finished product can contain hidden defects. If the soak time is too long, valuable energy is wasted. In some cases, excessive firing can even deform the tiles. Maintaining this thermal plateau requires continuous control. The thermocouple keeps measuring. Now let's see how everything works together. As soon as the kiln temperature changes, the thermocouple detects it and sends the new reading to the PID controller. The controller compares the actual temperature with the target, calculates the correction, and sends a command to the servo-controlled gas valve. The valve adjusts the gas flow. The burner responds. The kiln temperature moves back toward the set point. Then the thermocouple measures the temperature again. This cycle repeats every second, keeping the kiln stable and the firing process accurate. Every high-quality ceramic tile depends on this simple but intelligent control system. The thermocouple measures. The PID controller decides. The servo valve adjusts. 3 components, 1 control loop, millions of perfectly fired ceramic tiles. If you enjoyed this video, please like, subscribe, and let me know in the comments which kiln component you'd like to explore next. Thanks for watching.